Well, welcome to episode 1.4, Measurements in Chemistry. We just got done talking about the scientific method, and so now we need to move forward with that. And we talked a little bit about experiments. And so experiments and data, we got to be able to collect data. And so one of the things that we talked about um, was this idea of qualitative versus quantitative. And as we take a look at those words, we can see from those root words, um, we've got quality here versus quantity. And so the qualities of things are things like characteristics, physical characteristics. Whereas quantities obviously deal with numbers. And so, you've got characteristics like color and shape and things like that. Numbers, though, require some type of measurement. And so that's where we are going with this today. We're going into measurement. All right, so we take a look at the types of measurements that can be made, and we see that there are 7 basic types of measurements. Now you say to yourself, I think I could probably come up with at least 7, if not a whole lot more than 7 different types of measurements. Well, that's exactly true. There are definitely more than 7 measurements. But notice that I have underlined there basic measurements. All of the other types of measurements or units that you can come up with are combination units of these 7 basic ones. So what would be a basic measurement, do you think? Can you come up with a few? Sure, you probably gave it a good try there and probably hit 2 or 3 of these. And we'll start off here with mass. Hopefully you came up with the idea. That's a pretty basic one of mass, measuring that. The basic unit that we use for mass is the kilogram, but you'll notice there that I have gram in parentheses because when we're in the lab we are generally dealing with things a little bit smaller level than the kilogram, and we'll talk about prefixes in one of the assignments that you'll do, but we'll basically be dealing with grams in the laboratory. Another basic measurement is length. That's meter. We will be measuring a length a little bit, and usually when we do it will be in the centimeter, and I didn't really put that in the slide there, but anyway, another type of basic measurement that we'll be measuring in lab is temperature, and I did put this here. We measure in Celsius, but the basic unit according to the SI system, the System International, better known as the metric system, although there is little subtle differences between the two, is the Kelvin. And Kelvin is used when we deal with the mathematical side of temperature. Time is another important one. We measure that usually in seconds in the laboratory, although there's cases where you might want to measure something in minutes or hours, or days, or even years for that matter. And another important one in the chemistry laboratory is the number of particles, and that is measured in moles, and that's probably one that you're not familiar with, but you will become familiar with as we go throughout. Now these are the 5 measurements that we will do in the chem lab. But you say, well, there's 7, aren't there? Well, yes, there are. There's 2 more, but we don't really deal with these much in the chemistry laboratory. And number 6 is electric current. That's a pretty good physics topic. And light intensity, which is measured in candelas. That is the unit. We won't deal with those last 2 here in the chemistry classroom. But those are the 7 basic ones. All others are combination units. Let me give you a quick example of that. When you look at your speedometer and you're talking about speed of something, you're usually talking about something like miles per hour, right? Length, time, basic units, combination unit. All right? So that's how that goes. Okay, well, in measuring numbers, we're going to be using tools to do that. And the type of tools that we use in the chemistry laboratory, we use a balance. We have a couple of different kinds of balances. We have a triple beam balance and we have a digital balance, and we'll be using both. We have thermometers to measure temperature. We will sometimes measure length, but not real often, and that is going to be using a ruler or meter stick. And the last one that we'll be using, you probably haven't used before, is, maybe in biology, I guess, is a graduated cylinder. Is the fourth one. Now, when you're reading those tools, there's three things that you must do in every measurement. Every time that you measure, there are three things that you must do. The first one that you must do is first determine what the scale is. Determine the scale. These, what I'm talking about here, are the markings on the tool. Or you could call them graduations, as in graduated cylinder. That's talking about the markings. That's the first thing. Look at the scale. What is the scale telling you the markings are? The second thing that you must do, from those markings, you need to estimate. You need to estimate one digit past smallest marking. So that's why you have to figure out the scale first. Here's why. Let's say we have something that's between 1.1 and 1.2. The markings are 0.1 and 0.2. What if it's in between those two? We need to estimate. Alright, and so that's why there's one more digit. One digit past the smallest marking. Okay, so find the smallest marking. One more digit is where every number should be from that tool. And the last thing is pretty easy. Don't forget to write down the unit from that tool that you're using. Okay, those are three important steps. So let's take a look at a couple of examples here of those four different tools. We have the triple beam balance. Here's a good example. If you've never seen a triple beam balance before, the triple comes from their triple beam, is that there are 1, 2, 3 beams, and each beam has a slider. There's the hundreds, the tens, and the ones. Now if you notice, there are these little nicks in here, so the hundreds and the 10 slider have to be in those little nicks or grooves. Right? It's not a continuous slider. It has to be in those grooves. The ones and the smaller is a continuous thing. This thing just slides back and forth. Okay? So this will either be on the 100 or it will be on the 200. This will either be on the 40 or the 50 or on the 60. It will never be in between, so don't force it. Make sure it's in one of those slots. Now this little slider can be anywhere in here. And notice this little slider, as I was talking about before, is right between those two divisions. So the first thing you do, look at the scale. 4, 5, 6. So then that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of these is a tenth. Right? It goes to the 0.1. So when we read this, we go 144.5, but it's past the 0.5. Remember, the scale should give us 2 decimal places. 144.5, and it's halfway between 144.55. Okay? So that's kind of tricky. That's something people aren't real used to, and so you're going to need to do some practice with that. Well, here's another one, and then we're going to have to move on. Well, if I can get it to come up. There we go. I don't like that one. Let's try this one. This one's a good one. Alright. We have the 100 slider, 300. We have the 10 slider, is at 40. The 1 slider happens to be, looks like, right square on the 7. So what would we write? 347? Unit? If that's what you would write, you would not be entirely correct. Remember, we should be able to look at the scale and notice the divisions here go down to the tenths place, so then we should be able to estimate in the gap to the hundreds place on this particular device. Not all devices, but this one, we can get down to the hundreds place. So this particular number should be 347, because it's right square on the 7, we'd have to put 0.00. When somebody looks at our number, they realize that the tool that we're using is good down to the hundreds place. Or that last one is an estimate, right? Down to the hundreds place. All right? So always look at the scale, find the smallest division, go one more digit past that. Let's take a look at a thermometer. There's a pretty good one. Notice the scale, 80, 90. So then each of these must be, that's right, to the 1. All right, so we have 81, 82, 83, 84, 85, 86, 87, but it's not to the 88. So we would have to put 87 point, go estimate one digit past, 87.5. All right, get the hang of that. All right, well, let's take a look at a ruler. Here's a nice little line. We throw a little ruler on there, and we can control that ruler. So we bring it up here and we put it right next to our line. Notice it's right on the 0 and not the end of the ruler. Got to be careful about that. If this end of this ruler right here is not divided, we can't put it right here at the beginning. Right? We can't put it right there. And if the ruler happens to be divided all the way to this very end, I would recommend not starting at 0. I would recommend starting at 10. So if we did something like that, then it would look like this. We'd started at the 10, but then you've got to remember to shave 10 off when you take the reading. Okay? If it happens, because when, you know, these things go right to the end, they get nicked and damaged and rounded, and you don't know exactly where 0 is, and that creates error. All right, so let's read this real quick. We've got 95, looks like it's pretty much right on the 98, maybe a little past, and that's the estimate. You know, everybody's estimate is going to be a little bit different. So 98.0, maybe 98.2, 3, 4, 5. Any of those would have been acceptable as an estimate there. And the last one there, we got to turn off our graduated cylinder here, or turn off our ruler. All right, so let's take a look at a graduated cylinder. All right, scale 50, 60. So each of these is 1. All right, now when you're reading water in a graduated cylinder, we have this little layer right here that's called the meniscus. Okay. And so that meniscus, we read at the bottom. We read at the bottom right here. All right, so this is called the meniscus. All right, so we would be reading this 51, 52, not quite at the 53. Let me take those annotations off of there. So it's not quite to the 53, so it would be 52 point something. Estimate again. 52.5. If the divisions are small and it's hard to guess 0.2, 0.3, then just go with 0.5. And that's a safe estimate. All right? So, as we look back at these, you got to remember to look at the scale, find the smallest division, estimate one digit in between. For every reading, you should be thinking about what is the estimate, and then don't forget to put the unit on the end. Alright, so in the next episode, we're going to be taking a look at dealing with these numbers with something called precision and significant figures. And so I will just see you then.